Hello students, here we are going to discuss about momentum and Newton's second law of motion. Newton actually defined the momentum as the quantity of motion. Before discussing these two concepts, let us recap what Newton said about the first law. Newton's first law states that if there is no external force, then there is the body will continue to move with its uniform velocity. Means, for example, this is the body, it is moving with velocity v1. In the absence of the external force, at this position body's velocity will be again the same, that is v1. But if you want to change its velocity, then we need to apply some force, that is the external force. So external force is needed to change the velocity of the moving body or the body at the rest. Now Newton's first law do not give you any qualitative idea or quantitative idea how much force is needed to change the velocity. So that is actually given by the Newton's second law of motion. But before moving it directly to the Newton's second law of motion, Newton has defined the concept quantity of motion. So what is that quantity of motion and how it is related with force? Let us imagine the situation. Imagine the situation that you are standing at the middle of the road and one truck is about to move with very small velocity. It is heavily loaded truck. So truck is very heavy, but it is moving with very small velocity. Still you will move away from this truck because you have the fear that it may hurt you bad, hit you bad. Though you know that it has heavy mass and it is moving with very less velocity. So though truck is moving with very small velocity, but due to its heavy mass, you think that if it hit you, it will hurt you bad. Consider the second situation. You have a bullet and you are throwing, you have the target and you are throwing that bullet with the hand. Suppose this is bullet v1 and the velocity with which it is going to strike here, that is v1. Now there is another bullet and it is fired with gun and it is striking the target at the velocity v2. Naturally, both the bullets have the very small mass, maybe in grams, but the velocity with which it is fired with gun is too heavy. That means velocity with which it is fired with gun is much more than the velocity which with it was thrown with the hand. Still, the impact of the gun on the target is very high when it is fired with higher velocity. So here, though mass is negligible, velocities is depending the force which with it is striking on the target. So here force here depends on the mass. In this case, force depends on the velocity. Consider the another situation where you are going to catch a ball. This ball has some momentum, that means it has some mass, and with some velocity it is going to strike on the hand. When it is going to strike on your hand, the velocity is going to come to the zero. But in what amount of time this velocity, the striking velocity, is going to be zero? If you able to extend that time, the force with which it is striking on your palm will depend. Means if you pull your hands back, so velocity will not, the velocity will not be zero in the moment. It will gradually come to zero. That means here, if you allow the velocity to reduce to zero in larger amount of time, the force with which it is going to strike your hands will be less, and thus force depends on one more quantity, that is time. Because here in this case, in the case of ball, the momentum with which it is striking and the last final momentum, that is final mass into velocity, that will be zero, and thus more time you are allowing for changing the momentum, less force will be there. So force actually depends on three quantities. Thus we have concluded that force which is required to change the state of rest and uniform motion depends on the two quantities, the mass, velocity, and the time. In fact, this is the Newton's second law of motion. It states that the force which is required to change the state of rest and the uniform motion depends on rate of change of quantity of motion. Quantity of motion is nothing but the momentum is product of mass and velocity. Now this rate is with respect to time. With respect to time. In mathematically it we will write it as F directly proportional to d by dt of P. Generally momentum is represented by small letter p. If I solve it further, F is equal to K, it is the constant of proportionality, d by dt, and P will be replaced with mass into velocity. For the moving object, its mass will not change, so it is a constant. So it is K into m into dv by dt, where dv by dt is nothing but the acceleration. So F is equal to K into m into a. Now we have yet not defined the unit of force. For defining the unit of force, generally we call it the SI unit as 1 Newton. For 1 Newton, K value is always taken as 1. So F is equal to MA if we are using the SI units, and 1 Newton, force of 1 Newton is a standard unit when mass of the moving object is 1 kg and acceleration is 1 meter per second square. Thus, according to Newton's second law, the force which is required to change the state of motion depends on the three quantities, mass, velocity, and the time with which velocity is increasing or decreasing. So Newton's second law gives the mathematical method, or what you can say the quantitative method, to calculate the force required to change the state of motion.